Good morning, lovely. Sorry that I am out today. I have a sick child, so hopefully I'll be back tomorrow. We are going to do undoing powers today. So we're going to undo square roots, cube roots, and see what we get. And this is going to help us to be able to solve more advanced problems later on. So what is the square root? The square root means that two numbers came together, multiplied together, and made 81. So in that case, that's 9, because 9 times 9 is 81. The cube root means that three numbers, and they have to be the same number, all multiplied together equals 27. So that's going to be 3, because 3 times 3 times 3 is 27. Okay, in your calculator, you're going to press 3, the button that says math, and the number 5, and it will give you a cube root. If you want a fourth root, you just change whatever this number is. So the first number you type in, if you want a cube root, is 3. Then you're going to press the button that says math. It's on the left-hand side. And then the number 5, and you are going to have a cube root so that you can use your calculator for these portions. All right, how do we undo powers? So right now we have m squared is equal to 16, but we want to know what just m is. So to undo a square, we do a square root. Now the tricky thing here, or at least one thing to remember, is anytime we introduce the square root like we just did, we put a square root on the left and a square root on the right, we have to count for two possible options. So in this case, and again, you can type this into your calculator, there is a square root button on your calculator, but in this case, we're gonna get 4, but it's gonna be plus or minus 4, because 4 times 4 equals 16. But negative 4 times negative 4 also equals 16. And because I introduced the square root, I don't know which m I'm starting with. It could have been the positive or the negative option. So this has two possible answers. They also asked us to use radical form to simplify these. So when we take the square root and it's not a perfect square, like in the case of 12, we have to factor out, and we're looking for a perfect square that is inside of 12, like 4 and 3. The square root of 4 is 2, the square root of 3 is just 3. So we end up with plus or minus 2, the square root of 4 coming out as a 2, times the square root of 3. That one cannot be simplified any further. It doesn't have any perfect squares. And again, two possible options, because we don't know if two positives came together to make positive 12 or if two negatives came together to make positive 12. Now we're going to take the cube root of 25. So again, in your calculator, you're going to do this 3 math 5 thing, and you're going to get that f equals 5. Now notice we don't have a plus or minus option here, because if we were to do positive 5 times positive 5 times positive 5, that would equal 125. But if we were to do the negative option, negative 5 times negative 5 times negative 5, we would get negative 125, not positive 125. So that option doesn't work. So we only have one possible option, the positive option. All right, now we're going to be doing problems that you have done before. We're manipulating these equations, moving everything away from the variable we're attempting to solve for. But now we're going to have to also undo some powers. So right here, the first thing I see is that I want to get rid of this 10. I want to move it to the other side. So to make a zero pair here, I'm going to subtract 10 because it's a positive 10. So on the left, I have negative 72 equals negative 8n squared. These 10s just canceled out. Next thing I'm going to do is divide by negative 8 on both sides. Divide by negative 8. And we get 9 equals n squared. Now I want to take the square root of both sides. Remember, when we introduce the square root, we can get two possible answers. The square root of 9 is 3, so we get plus or minus 3 is equal to n. And again, you could plug these in and double check that it works. These should work. Both options should work. On our next problem, we're going to start by subtracting 2 on both sides. We get 168 is equal to 6c squared. Sorry, my pencil was being weird there, is equal to 6c squared. Then we need to divide by 6 on both sides. And we get 28 equals c squared We take the square root of both sides, noting that we're going to get 2 potential answers here. 28 is not a perfect square, but it has 4 inside. So we can take a 4 out. Which is 7, of course. And the square root of 4 is 2, and the square root of 7 is not going to be perfect. So we're going to get 2 root 7. And again, plus or minus, because this is a square root, there could be 2 possible options. Highly recommend you pause the video and try the next 2 on your own, but I'm going to do them as well in case you need my support. So we're going to add 7 to both sides. Again, we're starting by moving everything away from this y because we want y by itself. Negative 9y equals negative 18, and we're going to divide by negative 9 on both sides, and we get that y equals, y cubed. Drop that cubed up there. That's problematic. We get 2, the cube root, or y cubed equals 2. So now we need to take the cube root of both sides, not just the square root. And we get that y equals the cube root. So see that little 3 is just tucked into the little radical groove there. And that is your answer. That can't be simplified any further. If it asked for a decimal, you would do 3 math 5 in your calculator and give me an approximate. But if they want an exact answer, you need to leave that radical in there because this is not a perfect number. It's an irrational number. We subtract 7 on both sides in this next example. We get negative 3 equals negative 3b cubed. We divide by negative 3 on both sides. 1 equals b cubed. Take the cube root on both sides. The cube root of 1 is just 1 because 1 times itself 3 times is still 1. So in this case, b equals 1. All right, so that's how we undo powers. Now we have a couple of review problems. Asks us to write the equation that passes through the line or passes through these 2 points. Again, I highly recommend you pause this and try it on your own, but I'm going to do it as well. First thing I want to know is what is the slope of this? So we're going to do change in y, y2 minus y1, over change in x, x2 minus x1, and that's going to equal my slope. So in this case, I'm going to do negative 2 minus negative 5 over negative 8 minus negative 4. So these become pluses, right? Negative 2 plus 5 is 3. Negative 8 plus 4 is negative 4. So we end up with a slope of negative 3/4. And they want the equation of a line. So the easiest way to get the equation of a line when you have slope and a point is to go into point slope form. Point slope form says y minus y1 equals the slope times x minus x1. So I'm just going to pick this point 8, negative 2, and I'm going to do y minus negative 2, my y point, equals my slope, negative 3/4, times x minus my x point there, which is negative 8, so minus negative 8. So now we have y plus 2, written a little bit nicer, equals negative 3/4 times x plus 8. And that's point slope form. You could leave it like that. If you really wanted to have slope intercept form, you would distribute and then subtract the 2 on both sides, and then you'd be in slope intercept form. But if it doesn't tell you what form they want, point slope is always fine. Next review problem. If you place a 23-foot ladder against the top of a building and the bottom of the ladder is 11 feet from the bottom of the building, how tall is the building? Okay. So we don't know how tall the building is. I'm just going to call that X for now. We do know that my ladder over here that's leaning against is 23 feet. And we know that we are 11 feet away from the wall. This is Pythagorean theorem. A squared plus B squared equals C squared. Now remember, C is always opposite that 90-degree angle. So in this case, C equals 23. So A and B can change orders, doesn't really matter, but in this case, I'm going to say A squared plus 11 squared equals 23 squared. And now we just have to do a little bit of math here. 23 times 23 is what 23 squared means, so that's 529. 11 times 11 is 121, so we have A squared plus 121 equals 529. We're going to subtract 121 on both sides. And we get that a squared equals 408. Now we want to take the square root of both sides. And it said in the directions, we want to round this to the nearest tenth of a foot. So I'm guessing this is not going to be a pretty whole number. So we want to take the square root in our calculator, which my calculator is not wanting to do that. What is going on here? Okay, calculator not doing the square root of 48, so you're going to do that in your calculator because my phone will not change sideways so that I can get the square root button right now. But anyway, you're going to type this into your calculator, square root of 408, and you are going to round to the nearest foot, so a nice whole number there, and I will check in with you on that one tomorrow. Hope you have a lovely day.